we're talking about density. We're talking about how compact, how close are the atoms inside the object's volume. So in a given volume, how close are the atoms compacted together? And we're going to look at how the mass and volume relate to density and what factors influence the mass and volume to alter density, because you can change the density of an object if you do something to the other variables. But there's also a condition that if you do something that the density remains constant, and we're going to talk about that as well. So let's take a look. In this diagram, in the diagram that I have over here, you have a specific volume. And over here, you have the same volume. But the material that's over here, look at how the atoms are all compacted together inside this volume of space versus the atoms of this sample over here. Which one do you think shows a closer, smaller gaps or spaces between atoms, A or B? Which one has the least number of gaps or space between the atoms? Well, the answer is A. A is tightly compacted. It has more mass in that volume, and therefore the density of A is higher than the density of B. Simply because of the definition. Now we're looking at the definition. The definition says that the more compact the atoms are, the higher the density. The more the atoms are spread apart, the lower the density in that given volume. Remember, the volume stays the same. To calculate the density, you would need to know the mass of the object, and you want to divide it by the volume of the object. That is why we went over how to take the mass reading of objects and how to take the volume readings of objects, because now you're going to use that skill to then calculate the density of a sample. So you need to know the mass of the object and the volume of the object. We're going to divide mass divided by volume. That'll give you the density. Now if you look at the units, the mass unit is grams. The solid volume unit is centimeter cubed. So the unit for density would be grams per centimeter cubed. If we're dealing with a liquid, then it would be grams per milliliter. So it depends on what type of sample you're looking at. But the formula is exactly the same. It's mass divided by the volume. Now we want to look at relationships, and I think it'll be easier if I go over the relationships with you. But here you have the relationships here. That when you have mass increasing and the volume remains constant, the density increases. If the mass of a certain volume drops, decreases, then the density will decrease, all when the volume remains the same. So we're going to look at this condition. We're going to take a look at this condition also, that for volume now, if mass is constant, if mass is now constant, if the volume increases, the density will decrease. If the volume decreases, the density will increase. We're going to look at these two conditions and see why this happens. We're going to look at them mathematically. We're going to see why this happens. So just as a little recap here, I have two samples with two of the same volume. The volumes are the same. Two different samples, but the volumes are the same. This sample is showing that the atoms are tightly compacted. This sample shows that the atoms are loosely compacted. So the density of this object is going to be higher than this object because the atoms here are more compact, it's got more mass, and so on. So the density for this one is higher than so say density A is higher than density B, this being A, this being B. Simply because of compactness. A is more compact than B, A has a higher density than B. So let's look at the relationships. Let's take a look at those relationships we just saw before. So for density, I'm going to keep my volume the same. So I'm going to give you, here's one volume, and here is roughly the same volume. I'm going to tell you that the volume is, we'll just say it's 10 centimeters cubed. That's the volume of the sample. The volume of this sample, 10 centimeters cubed. So I should say the container, not the sample, our containers. So it's a cube, and it's going to be filled with material inside. Now I want to know what happens when I put mass and I change the mass. So when volume is constant, we want to know what happens here. So I'm going to put in my starting mass. So we're going to use the circles again. So here's my starting mass. So I'm just going to put in 1, 2, 3, 4, 5, 6, 7, 8, 9 circles. And I'm just going to say that my starting mass is 9 grams. Okay? This is completely made up, but I want 9 grams there. And I want to calculate my density. So density is mass over volume. So that's 9 grams over 10 centimeters cubed. That means my density is 0.9 grams per centimeter cubed. So this is my starting mass, or starting sample. Now, I'm going to add mass. I'm going to change my mass now. Looks familiar, looks like the other one, right? And let's say now my new mass is, let's say the new mass is 100 grams. It's 100 grams. So my density is equal to mass over volume, which is 100 grams over 10 centimeters cubed. Okay, my density then equals 10 grams per centimeter cubed. This is my new sample. Same material, I just changed the number of mass in the same volume. What happened to density? When I increased my mass from 9 to 100, the volume stayed the same. What happened to my density? What happened to my density? So when volume is constant, and mass increases, density increased. If mass decreases, what do you think is going to happen? Let's say that was my original mass. Then it went this way. So I was here and I took out a whole bunch of mass. What would happen? The density would also decrease. So this is called a direct relationship. Mass and density have a direct relationship to one another. Remember, volume is constant, so the volume was unchanging. All I changed was my mass concentration. When I increased my mass, density went up. When I decreased my mass, my density goes down. When my volume remains constant. Now what happens when mass is constant. So let's take a look at density again. And I'm going to have my mass remain constant. So here's my I'm going to start off with this volume here. And I'm going to start off with a specific number now of 9, 2, 3, 4, 5, 6, 7, 8, 9 atoms, let's just say. And my density here, or I should say my volume, let's say the volume here is 1 centimeter cubed. And my mass, well, I'll use it again, we'll use 9 grams. So my density, mass over volume, equals 9 grams over 1 centimeter cubed. So my density is equal to 9 grams per centimeter cubed. Now, remember, mass is constant, unchanging. So now I go to a new volume. And my atoms have an enormous amount of room to spread out in. So I have 1 there, 2, 3, 4, 5, 6, 7, 8, 9. Notice the distance between them has increased. When my volume increased, notice the distance between them increased. I have 9 particles here. The same 9 particles now are in here, but my volume increased. So they got more space between them. Let's look what happens. So my mass still equals 9 grams. But my volume equals 10 centimeters cubed. So I changed my volume. My mass stays the same. But my volume changed. I increased my volume, went from 1 to 10. Let's find out the density. Density equals mass over volume. That equals 9 grams over 10 centimeters. Oh, that was supposed to be, 10 centimeters cubed. So now my density is 0.9 grams per centimeter cubed. What happened? I was 9, I'm now 0.9. I had a volume of 1, I grew the volume to 10, so my volume increased, but what happened to my density? It went down. So in this case, when mass is constant, if your volume goes down, your density will go up. If your volume goes up, your density will go down. This is called an indirect relationship. Indirect relationship with the two. So, I hope you've got that settled. There's one more piece I want to tell you about this, and we'll do that in a moment. Let's look at an example here. Now, the other 2 examples I was giving you were when one of the variables were constant. In other words, when mass was constant and I changed the volume, density changed. When I had volume constant and I changed the mass, mass changed. And the way they changed we went over. But there's a change. What happens if I change both variables? And what I mean by that is I have a sample and I'm going to cut it in half. Let's just say I cut it in half. That means I'm changing the mass and I'm changing the volume. What happens to the density of the object? Well, let's take a look at our sample X. So sample X is measured to have 10 grams and a volume of 10 centimeters cubed. and I want to know the density. Well, hopefully by now you can do this outright, and the density is going to be 10 grams over 10 centimeters cubed, which is going to be 1 gram per centimeter cubed. So now let's cut this in half. Let's cut sample X in half. What happens? Well, when you do this, the mass and the volume break down proportionately. That means my mass now goes to 5 grams and my volume now goes to 5 centimeters cubed. So when I work the density, I get 5 grams over 5 centimeters cubed, which is 1 grams per centimeter cubed. If I cut the sample in half again, the density will be 1 gram per centimeter cubed. If I cut the sample in half again, and again, and again, and again, and again, and I keep doing this, my density remains the same. So the object's density, when we're measuring it out at room temperature, that's important, and you're going to find out why that's important, but right now, just know it's important. The density of the object is constant. It doesn't matter how big the sample I give you. Somebody next to you might get a big block of gold, and you might get a little nugget of gold, but because they're both gold, the proportions based on the amount of size you have, the volume you have with the mass, will be the same density of what gold should be at room temperature, regardless of the size of the sample. So let's look at another example just so I can prove my point. So here's another sample X. I'm not going to call it that, but sample XB. And we say that sample XB has a mass of 18 grams and a volume of 6 centimeters cubed. So if I want to find the density of the sample, I would just do 18 grams over 6 centimeters cubed, and that gives me 3 grams per centimeters cubed. If I cut that in half, then my mass became 9 grams and my volume became 3 centimeters cubed, and that becomes, density is 9 grams over 3 centimeters cubed. That gives me 3 grams per centimeter cubed. Notice how they remain constant. Not to each other, because they're two different samples. So gold and aluminum, they're two different samples. But within themselves, if I took gold and cut gold in half, the density of the two halves is the same as when it was together. If I cut each half in half, I took the density, then the density of those little pieces will be the same density as the one piece in the beginning. If I keep doing that with gold, I'll always get gold at the same density. So that's a nice little example. But the problem is, and it goes back to what I was saying before, is that can I influence density change? Can I cause a material to have a density change? And the answer is yes, I can. Yes, I can. And the two influences that we're going to look at are going to be temperature and pressure. And how does that influence a change? How does that influence a change? Let's look at temperature. Okay. So I'm going to start off with a sample. I'm going to start off with a basic sample. So here I have my container, and in my container I have my material, okay, and that's okay. And I'm going to say that the temperature, the temp is room temperature, which is 20 degrees Celsius, just to have a starting point. That's all it is. It's just a starting point. And I'm going to just show you that the mass, I'm going to say the mass is, what do I have here? 4 is, we'll just say it's 12 grams. And I'm going to say the volume is 1 centimeter cubed, just to make life easy. So I know my density will then be 12 grams per 1 centimeter cubed, or 12 grams per centimeter cubed. That's my density. Now what I'm going to do is I'm going to increase the temperature. Now, when you increase the temperature on something, let's say I make the temperature go to 100 degrees Celsius. What usually happens to the size of the object when the temperature on the object goes up? It expands. The object actually expands. So the volume is going to expand. So the volume will do this. Does the temperature change the mass? No. So now the 12 items spread out. Now you've seen this combination before, because the mass is 12 grams. That didn't change, but my volume did. I'll make this 100 centimeters cubed, just to play around with the numbers. Okay. So what's my density? Density would be 12 grams over 100 centimeters cubed. This is going to be, so it's 100, so it's 1, 2, so it's going to be 0.12 grams per centimeter cubed. So what happened here? My temperature, my temp increased, and what did that increase in temperature cause? My volume to increase. And what happened to the density when that happened? The density decreased. So temperature increased, caused the volume to increase, and when we saw before, when the volume increases, the density will decrease. So we say that temperature to volume equals direct relationship, because temperature went up, volume went up, so they both did the same thing, and temperature and volume to density are indirect. Indirect relationships, because they did the opposite. Temperature went up, density went down. Volume went up, density went down. So these two are direct, and then both of them are indirectly related to density. When temperature goes up, your density goes down. When volume goes up, your density goes down. Now you can do the opposite. I'm not going to do that here, but you can do the opposite. When temperature drops, right? So if I go this way and that way, when temperature drops from 100 to 20, the volume shrinks, which causes the pieces to compact, and when they compact, the density has to go up. Let's look at pressure. Pressure is a little bit different. Okay. So I have a container. I have a container here, like this, and I'm going to fill up the container. It's open. It's an open-ended container with material. Okay, 9 pieces. And I'm going to have the same container over here. But this time, I'm going to push down on a plunger. So I'll put it over here. I guess I'll put that over here too. Have it up here. Okay, so I have that here, and then I push down on it. So this is being pushed down. That's being pushed down. And what happens is if I get this. Now, just without going into any math, what is happening here? As the pressure, as the plunger is being pushed down, what's happening to the space between the items? They get smaller. That means they're getting compact. If they're compact, that means the density is doing what? Density is going up. Density is going higher. So if I go in this direction, if pressure increases, what's happening to the volume of the material? The volume of the material here is this big. The volume of the material is that big here. What's happening? Volume, put pressure on it, volume. Volume, volume. What's happening to the volume? It decreases. And when volume decreases, since it's inversely related to density, what happens to density? It must increase. So pressure is directly related to density. Meaning when pressure goes up, density goes up. When pressure goes down, density goes down. They're directly related to one another. Temperature, indirectly related. So when temperature goes up, density goes down. When temperature goes down, density goes up. How is temperature and volume related? They're directly related. When temperature went up, the volume went up. When temperature goes down, the volume went down. So they're directly related. How does pressure and volume work? How does pressure and volume work? When pressure goes up, the volume went down. When pressure goes down, the volume went up. So these guys, this is an indirect relationship. Okay? So I hope these little notes, these little side notes help you. The notes themselves go over this step by step by step, very, very carefully. I would recommend that you go through the notes thoroughly with that on pressure, the relationship between pressure and density, temperature and density, and so on. It literally goes through nice step by step scenarios. If you have a problem between that and this lesson, then definitely come see me. Ask me questions in class, please.